Okay, here we have our last example, and that's D. As I look at D, it's not even a division question right now, it's a subtraction question. So how am I supposed to reduce things when it's a subtraction? Well, the nice thing is these are two logs, and logs with the same base. We do have log rules that say if you have a log of base 6 with an argument, and you're subtracting a log of base 6 with a different argument, you can combine these by dividing the arguments. So that's the first thing I'm going to do. Log base 6 of x cubed minus 9x squared plus 26x take away 24 divided by the second argument of x squared minus 4x. So far, so good. Now I see that I have a division here and a possible way to reduce. But the problem is I can't reduce anything until I can factor both top and bottom and find those common factors to reduce. So what do we do with the top here? How can I factor the top? Unfortunately, as I look at this, I cannot group two terms and two terms and get a common factor. So that method is not going to work for me this time. I think I'm going to have to go to using the factor theorem on this one. And I realize that my PF, or possible factors for this, with a P of negative 24 and a Q of 1, are as follows, plus or minus either 1, 2, 3, 4, 6, 8, 12, or 24. Those are all my tester numbers. And as I start testing the remainders, hopefully getting a remainder of 0, you guessed it, remainder of 1, or sorry, the remainder or the function at 1, unfortunately does not work. It gives me an answer of negative 6. The function at negative 1, let's test that next. Well, that gives me negative 60. Still doesn't work. What about the function at 2? When I plug in 2 into this function here for x, I get a remainder of 0. That works. And that's great. That means that we have a factor now. X minus 2 must equal 0. That is a factor that works, or a root of 2, same thing. Let's either use long division or synthetic division to divide this out. Now I'm going to go very quickly here and skip a few steps because I know you all know how to do this. It's going to be very quick. The answer, or the quotient to this when I divide out an x minus 2 as a divisor, is x squared subtract 7x plus 12 with a remainder of 0. It should have been 0 because we already know that the remainder is 0 up here and we know it's a factor. So we know now that it's x minus 2 times x squared minus 7x plus 12, but this can be factored even further into x minus 2 times, you know how I love to ask this question in class, give me two numbers that multiply to give 12 and add to give negative 7. What are they? Anthony? X minus 4 times x minus 3. Okay. That's great. We've factored the numerator. So I'm going to write that down as my factored version of this numerator now. This x cubed, or cubic, becomes x minus 2 times x minus 4 times x minus 3 on the top. How can we factor the bottom? This looks kind of like a difference of squares, except the second term is not a perfect square because it's just x to the 1. 4 is good, but that doesn't work. What can I factor here? Well, I can common factor an x out. So x times x minus 4, like so. Have I factored everything on the top and everything on the bottom as fully as possible? Check. Okay. Look for factors now that you can reduce. How about this one and this one? Both x minus 4 and x minus 4 are going to give you the exact same answer. They can reduce 1 and 1. So what's our final answer here then? Log base 6 of x minus 2 times x minus 3, all divided by x. I didn't need to put that in brackets, I just did for out of habit. I hope this works for you. I hope this is understanding, and that you understand it, I mean. And I hope that you do well on your homework practice tonight. The homework practice is the next page of this note. I believe it's about a half a page. And I hope to see you all on Thursday.